Hello, everyone. I'm Michelle Bunty. I am the VP of Marketing for SOR Controls Group. We have a special treat. We have two of our finest temperature experts here to talk to you. They will be presenting about the specialty sensors we design and manufacture down in Houston, Texas. Greg Pryor is the business unit manager in Houston, and John Galey is the SOR regional manager for the Gulf Coast. They have been selling temperature for years and have more than 40 years of combined experience. Let's go ahead and get this event started. I give you John Galey and Greg Pryor.
Hi, thanks for joining us. My name is Greg Pryor. I'm the business unit manager at our facility here in Houston with our temperature group.
And my name is John Galey, and I am the Gulf Coast Regional Sales Manager for SOR Controls Group. So our agenda for today is we'll talk a little bit about who we are, and then we want to cover some special products that we offer, sample probes, multi-point sensors, surface mount sensors, high temp assemblies, and some custom or specialty assemblies. So the purpose of this presentation today is a lot of people know about our normal thermocouples and thermowells and RTDs, and we want to dive into a little bit more of the specialty products that you may not be familiar with or may not have noticed in our catalog. So who we are, again, I represent SOR Controls Group, so it's all the SOR brands. So we have SOR Inc., which most of you are familiar with, which is our pressure, temperature, level, and flow switches, along with our magnetic level indicators and our pressure and level transmitters. Those are all manufactured at our facility in Lenexa, Kansas. We also have, again, here in Houston is our Smart Sensors Group, which makes our thermocouples, RTDs, and thermowells, along with the specialty products that we're going to discuss today. And also located here in Houston is our sensor sampling systems as well.
So what makes us different? There are a lot of temperature companies out there. But most of them can build thermocouples and thermowells and RTDs. So what we wanted to touch on here is a little bit about what is the differentiator? Why choose SOR over somebody else? The first thing is the subject matter experts. Our group of temperature folks here, between our customer service department and our shop and production management, has over 90 combined years of experience in temperature. And that gives us an advantage right there. The consultative temperature selling aspect, our inside sales team is really good at problem solving and not just being able to sell you that off the shelf sort of thermocouple or RTD, but to be able to provide solutions to problems you have and come up with creative ways to solve those. We can do quick turnarounds on standard quotes. We can do quick deliveries. We're located here in the Gulf Coast, especially for anybody down here. We can put things on a hot shot and get it to you in a matter of hours. And then the engineered to order piece is, and we'll talk a little bit more about it as we get into this presentation, but it's really us being able to manufacture a solution that works for your very specific application that's not necessarily straight out of the catalog. Okay, so this slide is just letting us know a little bit about our customer base. I'm not going to go through all of these, but you guys can take a look. These are some of our larger, more high-profile customers that you might recognize. So we do a lot of business all across the United States from coast to coast, and these are some of the people we deal with. So the first topic that we really want to cover in terms of product is sample probes. So what is a sample probe? Some of you may be familiar with them. Some of you may not have ever dealt with them. Really, they're used in applications where you need to take a representative sample from some process, whether it's in a vessel, a pipeline, a tank, but you need to be able to pull a sample out without opening the process to the atmosphere. So Installing a sample probe typically with a valve mounted on the back end allows you to just open and close that valve, take a sample, or if you want to use it as an injection quill, to put a sample in. We can do flanged or threaded style. There are different ways to go about it depending on your process connection. We can do a retractable style sample probe where you'll also hear it referred to as hot tap. We can do single or multiple valves on the back end, depending on your process requirements, if you want to take samples in different directions. And we can also add other functionalities into a sample probe assembly, such as pressure or temperature measurement. Now, this drawing is really just a sort of standard type of sample probe. It's basically a flanged thermal well with the tip cut off at a 45-degree angle and a gate valve welded on the back end. You hook your sample line up to the back of that valve, and when you need a sample, you open it. When you're done, you close it. And so this is a pretty standard example of a sample probe.
So the sample probe examples you see, these are some pictures that we've taken over the years. We'll kind of go around counterclockwise. So starting at the top, just kind of shows you the view from the, like looking down the barrel of the gun there, basically shows you the thermal well with the tip cut off. So you can see the open bore through. Moving to your left, you see that's again another typical style of sample probe, and it gives you a decent view of the valve welded on the end. You can also see the opening at the tip. It's a much larger opening than the first picture, the one at the top. So we can do them in a variety of different IDs or openings. The one at the bottom is a really neat one, worked on years ago, where again it's taking a sample. I mean, you can see the little hole at the bottom, but it also is taking a pressure reading as well as a temperature reading. And then moving up to the right, that is a picture of a retractable style sample probe that we recently did here at the facility. And that's the one we're going to talk about here as a case study. So customer was Enterprise Products, and these were going on a flare line. And they actually had some existing ones that they needed to be replaced. And so we went out to the job site. They actually had one that they had pulled out that they needed replaced. And so I put it on the tailgate of my truck. We took pictures, we took dimensions, and I sent those off to Greg and his team, and they designed a new sample probe or retractable sample probe to meet exactly the requirements of the application. And we built them and installed them, and they're working great. So it was a really good win for us.
Okay, so our next product category that we want to talk to you about today are multipoint sensors. Now, multipoint sensor is a pretty broad category. They're usually used in applications where you need to get temperature profiling over distance at various points along that distance. They can come in a lot of different styles. One of the main ones, we kind of divide them into two groups. Typically, you'll see a pipe well style, which is what you see in this drawing here. And inside of that pipe well, we can either have guide tubes that use heat transfer blocks to allow the elements to be individually replaceable, or we can do positive contact bundles with springs that will keep the elements themselves pressed up against the ID of that pipe. Those are the larger style of multipoint. Then we also do mini multipoints, which are typically small diameter tubing. We can go down all the way to 1/8" tubing with multiple points, really small points inside along length. And then there are nonlinear multipoints where you have an application, maybe you only have one nozzle that you can enter, but you need to route those points to various places inside of a vessel or tank. We can do those as well through a single entry point.
And further on multipoint sensors, it's used for temperature profiling, like at different elevations inside a reactor, if it's a top mount, or maybe across a reactor bed if it's a side mount. Most of the time for multi-points, we use thermocouples. There are cases where you can use RTDs, but in general, most of these are thermocouples. And then secondary seals are available, and they're quite common if you're going into, again, like a reactor. So you can have a secondary seal. It can also be monitored for pressure, so you know if there's been any compromise to the pipe well. You can either use a gauge or a pressure transmitter. And then we do offer a variety of testing. Dye pen and hydrostatic testing are available, among others. And then we can calibrate the sensors as well as have a positive point identification, which is like say on a mini multi-point, it's just locating so that you know exactly where those temperature measurement points are along that tube. So mentioned a few of these, but typical applications, again, for the larger pipe well multi-points, we're looking at reactors, so hydrotreaters, hydrocrackers, distillation columns, as well as tanks or typical applications for the larger ones. And then for the mini multi-points, typically pilot plants and labs are where those are frequently used. So we'll move on to surface mount temperatures. And the first one we'll talk about is TUBESKIN thermocouples. So TUBESKIN thermocouples are used to measure the tube wall of a furnace tube inside the furnace. That helps to determine the life of the tubes and also the temperature trending on those tubes. Also can help you detect a coke buildup, as well as used in control of the process, as well as prolonging the life of the tubes. They can be customized in a variety of different ways. So we have expansion loops and different bends that we can do. So typically these TUBESKIN thermocouples are located on what we call the hot side of the tube. So that's the side of the tube that's facing the furnace, the fire, as you can see here. And then what we want to do is we want to quickly route the thermocouple to the cool side of the tube, or the side of the tube opposite the flame. So typically that bend that goes from the hot side to the cool side, we typically do that here. Most other bends are done in the field because as you know, what shows on paper is not what's always out in the field. And besides, sometimes it's hard to ship these things if they've got all kinds of crazy bends in them. So typically that bend around the tube is the main one we do, but we can do others. We have a couple different styles. Weld pad and wedge style are kind of the two most prevalent. And we can do a variety of different heat shields as well. So if you look at this picture at the top, this is what we would call a wedge style. There's a lot of different names for it. Different manufacturers have different names, but basically it's a block at the end of the thermocouple, and that block is in some kind of a V shape. And then that gets welded onto the furnace tube. And then the other style is the weld pad that you see here. Kind of get a better look at it down here. And that is typically welded to the tube on 3 sides. So on the 2 sides and the tip, not on this side. So that would be welded on the tube. And so it's affixed on the tube. And then generally they're affixed at the exit point, which is like you see here. There's different ways to do it. This is one typical way, but there's other ways to do it. So since these are affixed at 2 ends, that furnace tube is going to grow. So when you fire up that furnace, that tube is going to grow. So you have to have some way to compensate for that growth. And we do that generally by expansion coils. So that allows the thermocouple to grow with the tube and not break off. If you don't put expansion coils or S loops or something to accommodate that expansion, these things are going to snap, and typically they'll snap off right here where they're affixed. And then on this picture down here, you can see a typical heat shield. And so again, if you picture, this would be on the hot side or the side facing the flame, and then we quickly route that thermocouple over to the cool side, and typically it hugs along that tube to some kind of exit point. So it hugs along that cool side. And how we do that, accomplish that, is with these tube clips right here. And then we will quickly, once we get to the exit, we'll quickly exit outside of the furnace. So typical applications, again, there's a variety of different furnaces. We've listed several of them here, but furnaces and as well as boilers and superheaters are your typical applications for furnace tube skin thermocouples or just tube skin thermocouples.
Okay, so we talked about surface mounts as a category, and you've got tube skins that John just went over, but there are other types of surface mounts that we wanted to kind of touch on that you may come across and have the opportunity to use. A heat trace surface element you'll see is typically a 90-degree, and at the end that is a weld pad, just like the weld pads that we just discussed on the furnace tube skins. But these are typically used for electric heat tracing. So you'd put these on your pipe to help monitor the temperature for the heat tracing process. Sometimes you get into a situation where you need to be able to mount on a pipe or a vessel without being able to weld on it, because in order to keep it running, if you do any welding, you may have to rehydro test the whole system. Sometimes welding just isn't an option. So one alternative is the use of a magnet. There are a couple different styles. You'll see the one in the top right here. That's just a spring-loaded element and just sticks right on. Down here, you have the larger U-shaped magnet, and the spring actually holds down an element that's put underneath that spring mount. And then same concept, but instead of using a magnet, you can use a pipe clamp to hold that element tip against the surface. So this would typically be spring loaded. So once you tighten this clamp down, that element will actually be pushed up in here, but it will make sure, because of the spring, that you keep positive contact on your pipe surface. So that's another option for getting the surface temperature. Okay, so that's it on the surface mounts. The next category we want to talk about are high temperature assemblies. And when we're talking about high temperature, we're generally talking about 2000 Fahrenheit as sort of the threshold when you're really going to want to switch to what we call a high temp assembly. The reason that's around where you start seeing the change is because a lot of the metals that you would typically use in a thermowell or a standard thermocouple or RTD sheath, that you're starting to get to the limit of those, your Inconels and 310s. So you often at that point need to go to a ceramic like alumina or mullite. Hexalloy is another type of ceramic that is really good for corrosion. It's got a little bit more strength than the alumina tubes do. There are recrystallized alumina tubes, which are good for pretty nasty environments. We've sold those in incinerators, for example, as a place where you might see something like recrystallized alumina. And your elements, typically, you're not going to get an RTD at 2000 Fahrenheit. They just don't go that high. So you're already going to be in a thermocouple range, but this is where you wind up getting into your platinum elements, your type R, your type S, and your type B. They're also very high accuracy, and they can handle those high temperatures.
So typical high temp applications, again, I already mentioned incinerators, thermal oxidizers, sulfur recovery units. They're very prevalent in those units, and also in certain parts of the furnaces and boilers as well.
Okay, and then custom and specialty assemblies. This is a whole lot more broad of a category than all the others, in that it's not specific to any particular product. What we want you guys to understand is that we have the capability to help design and build a custom solution for temperature in all kinds of different applications. there are a lot of unique applications that pop up here and there where, we need to get a temperature reading, but we're really not sure how we're going to go about it. That's something that we have quite a bit of experience, especially with our inside sales group, to be able to help you with that process. So what's in the catalog is one thing. What we're talking about here are sort of the non-catalog type items. And so just because you don't see it in the catalog certainly does not mean that we're limited to what's in there. We can help you with a custom design, whether it's an improvement on an existing design or a new design altogether. We can help you with that process. And that's all very application specific. So the more information you have about what you're trying to accomplish, the better we'll be able to help you figure out how to go about it. We can also retrofit assemblies on existing equipment. There are a lot of larger pieces of equipment that may have come from Europe or overseas somewhere that are here, and now you need to replace the temperature elements, and they may have quirky fittings with oddball threads or something that's sort of non-standard for our day-to-day stuff. We can do all that as well. So really, to sum that piece up, if it's not in the catalog, that's okay. We can try and help you come up with a solution to whatever that application is.
Yeah, so in this particular case study, so we had a customer that came to us, and you can see, after increasing the run rates, their existing thermal wells were only lasting a matter of weeks. And so they actually talked to us, and they talked to, I think, 2 of our competitors. And the big thing is that we worked with the customer. So we had some ideas, the customer had some ideas. This was a, high temp, highly abrasive application. And our competitors just basically said, this is what you need. Where again, we worked with the customers, we went back and forth with the customer, and we came up with a solution with them. And so we competed basically our solution against the 2 other manufacturers. And not only did ours last longer, but the customer was most pleased with us because we didn't tell them what they needed. We listened to their thoughts, and we incorporated their ideas and their thoughts into the design, and it ended up being the best. So we won that business, and we have that customer as a longtime customer now.
All right, and that's the end of our presentation for today. So we want to thank you guys for joining us and tuning in to listen to us talk temperature for a little bit. If you need anything at all, give us a call, shoot us an email, go to our website. You can get all of our contact information there. And again, thank you for joining us.
Thank you, everyone.